Hello, I am Dr. Sigarkanti. In this video, we find some more reduction formulas. It is integration of the form x to the power of n into exponential, or x to the power of n into logarithmic, or x to the power of n into sin x. First one, find the reduction formula for x power of n into e power of ax. Okay, so here x power of n into e power of ax into dx. I will take first function as x to the power of n and second function as e to the power of ax, and integrating by parts. First function x power of n into integral of the second e power of ax integration is e power of ax divided by a minus under integral sign derivative of first x power of n derivative n into x power of n minus 1 into integral of the second e power of ax integration is e power of ax divided by a. So that is equal to x power of n into e power of ax by a minus n by a. I will write this n by a outside into x to the power of n minus 1 into e power of ax dx. So that is here x raised to n reduces to x to the power of n minus 1. Some examples: evaluate x into e power of ax into dx. So here we have n equal to 1. N equal to 1, then x into e power of x into dx is equal to x power of 1. So that is equal to x into e power of ax by a minus n by a, 1 by a into 1 by a into here I am taking n is equal to 1. This becomes x to the power of 0, that is equal to 1. Okay, so 1 into e power of x, that is integration of e raised to x. Integration of e raised to x is e raised to ax divided by a, and already one a is here. This becomes, denominator becomes a square. So that is here x into e raised to ax by a minus e raised to ax by a square plus c. One more example, evaluate x square into e power of ax dx. So we have x raised to n e raised to x dx equal to x raised to n e raised to x by a minus n by a into integral x power of n minus 1 into e power of ax. So here put n equal to 2. Then this becomes x square e raised to x by a minus 2 by a into x power of 2 minus 1, that is x into e raised to x into dx. So this is equal to x square e raised to x by a minus 2 by a into integration of x into e raised to ax. Integration of x into e raised to x is here. X e raised to x by a minus e raised to x by a square plus c. Okay. And multiplying we get like this. Another example, evaluate integration of x cube into e raised to x into dx. We have, this is the formula. Here we have to put n equal to 3. If I put n equal to 3, this becomes x cube e raised to ax by a minus n by a, that is 3 by a into integration x square e raised to ax dx. We know this integration x square e raised to ax dx is here. This is our x square integration of x square into e raised to ax dx. So here substituting here, then and multiplying we get x cube into e raised to x by a minus 3x square e raised to x by a square minus into minus plus 3 into 2 is 6 x into e raised to x by a cube minus into plus is minus 6 by a to the power of 4 into e power of ax plus c. Similarly, evaluate x to the power of 4 into e power of ax. Again here we put n equal to 4. If I put n equal to 4, I will get x to the power of 4 e raised to x by a minus n by a, that is 4 by a into integration of x cube into e power of ax dx. So already we have calculated this, evaluated this x cube into e power of ax into dx. So substituting here, replacing this. Okay, so this is the integration of x cube into e raised to ax, and multiplying by this, taking this 4 by a inside, I am getting x power of e raised to ax to dx is equal to, so this is the integration. Here, if the first function is some power of x, and if you know the repeated integrals of the second function, then we can use the general rule of integration by parts. What we do here is, this is the first function. You have to take algebraic function, that is x power of n as the first function and e power of x as the second function. What we need to do here is, just we have to write first function into integral of the second. E power of x integration is e power of x by a. Next you have to write minus n, plus minus plus minus plus minus, like this. Okay. What we do here is write minus sign here. Write the derivative of x raised to 4, that is 4x cube, into, write the integration of this second term here, that is e raised to ax by a. So this becomes a square. Next write plus, write the derivative of this 4x cube derivative is 12x square, into, write the integration of this. Integration of e raised to x is e raised to ax by a. So this becomes e raised to x by a cube. Next write negative sign minus, write the derivative of this 12x square derivative is 24x. Okay, 24x into, write the integration of this term. E raised to x integration is e raised to x by a. This becomes a to the power of 4. Next write plus sign, plus, write the derivative of this 24x derivative is 24 into integration of this term e raised to ax by a. This becomes e raised to ax divided by a to the power of 5 plus the constant of integration. Okay. So next one is find the reduction formula for x power of m into log x to the power of n dx. Okay. So consider the integration x power of m log x to the power of n dx. Here I will integrate this by parts. While integrating by parts, I will take log of x to the power of n as the first function and x power of m as the second function, because we know the differentiation of this log x to the power of n and we know the integration of x to the power of m. Okay, so that is first function log x to the power of n into integral of the second. X raised to m integration is x raised to m plus 1 divided by m plus 1 minus, under integral sign, derivative of first, that is the log x to the power of n derivative n into log x to the power of n minus 1 into log x derivative is 1 by x into integral of the second. X raised to m integration is x raised to m plus 1 divided by m plus 1. Now x to the power of m plus 1 by x is there. This becomes x to the power of m. So that is here log x to the power of n, x raised to m plus 1 divided by m plus 1 minus n by m plus 1. Okay, I'll write this outside. N by m plus 1 into log x to the power of n minus 1 into x power of m dx. So here the power of x remaining as it is, but we are reducing the power of this log x. So that is log x to the power of n was there. We have reduced it to the power of n minus 1. Okay. So that means after n times using this reduction formula, this becomes 1 and we can integrate this the second term. Example, evaluate x power of m into log x dx. So we have, so here my n is equal to 1. My n is equal to 1. Putting n, substituting n equal to 1, we get here log x raised to m plus 1 by m plus 1 minus 1 by m plus 1 into n equal to 1. So this becomes 1. So x power of m dx. And we know the integration of this. That is log x power of m plus 1 by m plus 1 minus integration of x raised to m is x raised to m plus 1 divided by m plus 1. Already one m plus 1 is here. This becomes m plus 1 square plus the constant of integration c. Second example, x raised to m into log x square dx. So this is our formula, reduction formula. Here we have to put n equal to 2. If I put n equal to 2, then this becomes log x square x raised to m plus 1 by m plus 1, this as it is, minus n by m plus 1, that is 2 by m plus 1 into log x to the power of n minus 1, log x to the power of 2 minus 1 is log x into x raised to m dx. This is equal to log x square into x to the power of m plus 1 divided by m plus 1 as it is, minus 2 by m plus 1 as it is. We know the integration of this. That integration of log x to the log x into x raised to m dx is equal to log x into x raised to m plus 1 by m plus 1 minus x raised to m plus 1 by m plus 1 square plus constant quantity c. Or multiplying this, we get here minus 2 log x into x power of m plus 1 divided by m plus 1 square. Minus into minus is plus 2 into x power of m plus 1 divided by m plus 1 whole cube plus c. Next example, x raised to m into log x cube dx. Again, here we have n equal to 3. N equal to 3. N equal to 3, this becomes log x to the power of 3, x power of m plus 1 divided by m plus 1 minus 3 by m plus 1. N equal to 3 here. 3 by m plus 1 into integration of log of 3 minus 1, log 2. That is log x square into x raised to m dx. And we have this integration here. Integration of log x square x raised to m dx. Already we have evaluated. Substituting for this, we get this is equal to this term as it is minus 3 by m plus 1 into integration of log x square into x raised to m is given by this log x square x power of m plus 1 by m plus 1 minus 2 log x into x power of m plus 1 by m plus 1 square plus 2 into x to the power of m plus 1 by m plus 1 cube plus constant quantity c. Multiplying, this becomes minus 3 by 3 into log x square x raised to m plus 1 divided by m plus 1 square. This becomes plus 3 into 2 is 6 into log x x raised to m plus 1 divided by m plus 1 whole cube. Minus into plus is minus. This becomes 3 into 2 is 6 into x to the power of m plus 1 divided by m plus 1 whole cube into m plus 1. That is m plus 1 to the power of 4 plus c. Next reduction formula. Find the reduction formula for x power of n into sin x. Again here I will take x power of n as the first function, sin x as the second function, and I will integrate this by parts. That is, first function is x power of n into integration of sin x is minus cos x minus under integral sin derivative of first x raised to n derivative is n into x to the power of n minus 1 into integration of the second sin x integration is minus cos x. So that is, this is equal to x power of n into minus cos x minus into minus plus n into x power of n minus 1 into cos x dx. So that is x power of n reduces to x power of n minus 1. But here, in this case, what is happening is I am getting this cos x. My function is x power of n into sin x. I need the similar function here. That is x power of something into sin only. So what I do here is Again, I will integrate this by parts. That is x power of n into minus cos x as it is plus n into taking x raised to n as the first function, n minus 1 as the first function and cos x as the second function. So first function x to the power of n minus 1 into cos x integration is sin x minus under integral sign derivative of first x power of n minus 1 derivative is n minus 1 into x power of n minus 2 into cos x integration is sin x. Okay, so that is this is equal to x power of n into minus cos x. This is plus n into x power of n minus 1 into sin x minus n into n minus 1 into x power of n minus 2 into sin x dx. Now this is the required reduction formula. See here x power of n into sin. Here also I am getting x power of something into sin. Here power is n, here power is reduced to n minus 2. So this is the required reduction formula. Let me go for an example. Evaluate x into sin x dx. What is the value of n here? N equal to 1. Put n equal to 1. Then we get x power of 1 is x into minus cos x plus 1 into this x raised to 0, 1. This is 1 into sin x and this becomes 0 because I am taking n equal to 1 here. So that is here x into minus cos x plus sin x plus c. This is the integration of x into sin x. Next I will consider another example, x square into sin x. Here n is equal to 2. This becomes x square into minus cos x plus 2 into x, 2 into x, n equal to 2 here, 2 into x sin x minus 2 into, this becomes 1, 2 into 1 is 2 into integration of x raised to 0. This is equal to 1 into sin x, that is integration of sin x dx. This is equal to x square into minus cos x plus 2x into sin x minus 2 into integration of sin x is minus cos x. So this becomes minus into minus plus cos x plus constant of integration is c. Next example is x cube into sin x. Here we have n equal to 3. So if n equal to 3, this becomes x cube into minus cos x plus 3x square into sin x minus 3 into 2, 6 into x power of 1, that is x into sin x dx. So that is x cube into minus cos x plus 3x square into sin x minus 6 into, what is the integration of x into sin x? Already we have evaluated this. This is equal to x into minus cos x plus sin x plus c. So that is x cube into minus cos x plus 3x square sin x minus into minus is plus 6x into cos x minus into plus is minus 6 into sin x plus the constant of integration is c. One more example, x power of 4 into sin x. Here n equal to 4. If I put n equal to 4, this becomes x raised to 4 into minus cos x plus 4x cube into sin x minus 4 into 3 is 12. 12 into integration of x to the power of 4 minus 2 is 2. That is x square into sin x dx. That is x raised to 4 into minus cos x plus 4x cube into sin x minus 12 into integration of x square sin x dx. Already we have evaluated this integration of x square sin x. So this is this term as it is, this term as it is, minus 12 into integration of this is x square into minus cos x plus 2x into sin x plus 2 cos x plus c. And multiplying we get here minus into minus is plus 12x square cos x and this becomes minus 24x sin x and this term becomes minus 24 cos x plus c. Here Here also we have first function is algebraic, that is x power of something, and second function is sin x. Here the multiple integrals of this is known here, that is integration of sin x, that is sin x integration becomes sin becomes cos, cos becomes sin, cos sin becomes cos, cos becomes sin, again cos becomes sin. So that means here the repeated integrations of sin x is known, therefore we can use the integration by parts, general rule of integration by parts. See, this can be obtained without this reduction formula. So what I do here is, see, x raised to 4 into sin x dx is here. I will write first function as it is x to the power of 4. Okay. And write the integral of the second, sin x integration minus cos x, first term, and this second term. Then write negative sign. That is first one positive, negative, positive, negative, positive, negative. Alternating, we have to write the signs here. Minus, what I do here is, this is the bracket. This is nothing but the derivative of this term here. X to the power 4 derivative is 4x cube into, this is nothing but the integration of the second term here, this bracketed quantity. Integration of minus cos x is minus as it is, cos x integration sin x. Okay. Then we have to write plus. Write the differentiation of this 4x cube derivative is 12x square into integration of the second minus sin x integration is minus cos x, minus of minus, this becomes cos x. Okay. Then write negative sign minus derivative of 12x square. This is 24x into integration of this second term, cos x integration is sin x. Then write plus, write the derivative of this 24x derivative is 24 into integration of sin x is minus cos x. Here this integration ends because in the next term what I have to do here is I have to write the differentiation of this term. Now with this reduces to constant quantity, this becomes 0. 0 into anything becomes 0. That is here after this step all the terms becomes 0. Therefore, if the first function is x to the power of something, and if we know the repeated integrations of the second function, then we can go for the general rule of integration by parts. Okay. Thank you. I will stop here.